Welcome back, and today we're going to try to do some practice questions on elemental composition of pure substances. And we have four questions. Let's go. You might need a periodic table. Alright, so we have four compounds K, KNO3, which have a molar mass of 101.4 grams per mole, KF, which has a molar mass of 58.1 grams per mole, KClO has a molar mass of 90.6 grams per mole, and KBr, which has a molar mass of 119.0 grams per mole. Based on the information in the table, which of the following compounds contains the greatest percentage of potassium by mass? Alright, so when we look at these four compounds, we can see that each of the compound contain one potassium because it KNO3, KF, KCO3, KClO, and KBr, it only have one potassium in the molecule. So it means that we can base on the molar mass only to judge the percentage of potassium by mass. So what does it mean by greatest percentage of potassium by mass? It means that with the mass of the entire compound, potassium contribute to the overall mass the most. So for example, if I pick out KF, it has a 58.1 grams per mole. So every 1 mole of KF or potassium fluoride, it is 58.1 grams. But and this potassium fluoride, it has potassium and fluorine. Potassium will contribute some weight to it, and so do fluorine. And it has 58.1. And every potassium has the same weight. But potassium fluoride, which has the lowest molar mass out of the four, it means that potassium has the greatest percentage. Because, well, potassium has the same mass, and 58.1 is the lowest. So it is the masses that is not potassium is the least, because the mass of potassium plus the mass of other things would give us the molar mass of the compound. If we can minimize the mass of other things, it means that the percentage of potassium or the mass of potassium would be the greatest. In this case, the mass of other things is the least is potassium fluoride. So therefore, B would be the correct answer. And let's check. There we go. Next question. A 152.0 grams sample of a compound contains 48.0 grams of carbon, 8.0 grams of hydrogen, and 96.0 grams of oxygen. Which of the following is the empirical formula for the compound? Alright, so we are dealing with 152 grams of sample of a compound with 48.0 grams of carbon, 8.0 grams of hydrogen, and 96.0 grams of oxygen. So from this, to make an empirical formula, we have to know the relative ratio of moles between each of the elements. So let's convert each of the element into their respective moles. So how many moles are there in 48.0 grams of carbon, you may ask? The way we can do this is to have 48, so we have 48.0 grams of carbon. To find amount of mole in something like in a compound or element, we would take so we have three things. We have mass, we have molar mass, and we have moles. And those three are related to each other. Typically, we want to convert mass to mole or mole to mass, and we would use molar mass to give us the way to convert between them. So let's see. So if we want to figure out how we can convert from grams into mole, let's check the unit of molar mass, because it's the way that it helps us to convert from mass to moles. So the unit of molar mass would be grams per mole, and it means that every grams per 1 mole. And using the unit, we can see that molar mass is equal to the mass, which is in grams, divided by mole, which usually symbolized by N. Mass is usually symbolized by M. And that will be the molar mass is usually symbolized by big M. So we have M over N is equal to N, equal to big M, and we want to find this N. And where we can find the small n, or the N, we can times N by both sides and divided by M, the big M on both sides. And now we have it. The mole is equal to the mass divided by the molar mass. So let's see. With carbon, we have the mass of 48. Let's put I have a calculator beside me. So we have 48 grams of carbon, and would divide it by the molar mass of carbon, 12.01. And that will give us 3.99669, so on and so forth. We would typically round that to 4. So that will be 4 moles. We would do the same thing with hydrogen. 8.0 divided by the molar mass of hydrogen, 1.008, and that will give us around 8 moles. So we have 4 moles of carbon, 8 moles of hydrogen, and let's check oxygen. 96 divided by 16.00 grams per mole, that will be exactly 6 moles. So we have 4 moles of carbon. So let's write out the ratio that we have. Let's write out the ratio that we have. 4 moles of carbon with 8 moles of hydrogen, and then with 6 moles of carbon, or 6 moles of oxygen. And with empirical formula specifically, it needs to be in the simplest ratio. So we can simplify this ratio even more to 2 to 4 to 3. So every 2 carbons we have 4 hydrogen and 3 oxygen. And what I can see is B would fit the criteria. So B should be the final answer. And we got the right answer. Let's go. A pure sample of a compound contains 60% titanium and 40% oxygen by mass. Which of the following is the empirical formula of the compound? So the same thing. To find out the empirical formula of the compound, we need to know the relative ratio between the 2 elements. And we have 60% titanium and 40% oxygen. We can assume that compound is 100 grams, and it's made out of 60 grams of titanium and 40 grams of oxygen, because 60% of 100 is 60, and 40% of 100 would be 40. So let's assume that that compound is 100 grams, titanium is 60 grams, and oxygen is 40 grams. And let's convert each of the respective compound into the moles. 60 grams of titanium. Like the last question, to find out the moles, we take the mass divided by the molar mass. We have titanium, which has the mass of 60 grams, and divided by the molar mass of the titanium, which is 47.87, and that gives us around 1.25. All right. Let's check 40 grams of oxygen. So 40 grams of oxygen divided by 16.000 grams per mole, and that will give us 2.5. So 1.25, let me write it down, 1.25 titanium to 2.5 oxygen. And what you can do is to make this do something legible, something that we can make sense of. So we can take 2.5 and divide by 1.25 to see how many times 2.5 is compared to 1.25, and it's around 2 times. So we can see that 2.5, 1.25, it's practically 1 to 2 ratio. And one other thing we can do, one other thing we can try is we can make this into 5 and this into 2.5, because we times each of the thing by 2. So now we can see it's practically 1 to 2 ratio. And one thing we can try to do is to find the answer that shows that titanium to oxygen has a 1 to 2 ratio. And only A has the criteria that we want to find: titanium dioxide, TiO2, and it has 1 titanium to 2 oxygen, and that will be empirical formula of the compound that we want to find. And that should be our final answer, and let's check. Perfect. And the next question would be the last question. A sample of a compound containing only carbon and hydrogen atoms is completely combusted, producing 110.0 grams of carbon dioxide and 27.0 grams of water. Which of the following is the empirical formula of the compound? So we have 110.0 grams of carbon dioxide and 27.0 grams of water, and we know that the compound we want to find only has carbon and hydrogen, and the products that we have, only carbon dioxide has carbon and only water has hydrogen. So we would want to find the amount of moles contained of 110 grams of CO2 for carbon and the amount of moles in 27.0 grams of water for hydrogen. And then the answer is, the question is asking us the empirical formula of it. So we want to find the respective or the relative ratio between carbon and hydrogen. So let's do that. So first of all, let's find how many moles of carbon is in 110.0 grams of carbon dioxide. And one way we can do this is to make 110 grams of carbon dioxide into moles of carbon dioxide. And the way we can try to find the moles by mass, like the previous 2 questions, is to take the mass divided by the molar mass. So we have the mass of 110.0 grams, and we want to divide it by the molar mass of carbon dioxide. We don't specifically remember, or we don't need to remember what is the molar mass of carbon dioxide. What we want to do is to use the periodic table and to figure out what is the molar mass of each of the individual elements and add them up. So in this case, we have one carbon which has 12.01, and then add in 2 oxygen, which is each of them is 16. So we would add 2 16 in, 16.00 plus 16.00. So let's put it in one calculation, and now we have 110.0 grams divided by everything down below, 12.01 plus 16.00 plus 16.00, and that will give us around 2.5 moles. So we have 2.5 moles of carbon dioxide. And each of the 2.5 moles of carbon dioxide, we have 1:2 ratio between carbon and oxygen. So we would want to divide, or we 1:2 ratio of oxygen. And whenever something has a ratio of 1, it means that it has the same ratio or the same mole as carbon. So for example, we have 2.5 moles of carbon. And we know that carbon has 1 oxygen, or 1 carbon and 2 oxygen. So every 1 carbon dioxide, we will have 1 carbon, because each of the carbon dioxide only contains 1 carbon. Every 2 carbon dioxide, it will contain 2 carbons. So now we have every 2.5 moles of carbon dioxide, it means that it has 2.5 moles of carbon. So now we figure out we have 2.5 moles of carbon, and let's do the same thing as water to find out the moles of hydrogen that it has. Let's do the same thing. We take the mass, 27.0, and divide it by the molar mass. We are not sure what the molar mass of water is, so we would take the individual elements molar mass and add them up. We have hydrogen, which has 2 of them, so we have 1.008 plus 1.008. And then we'll plus 16.00 because we have 1 mole oxygen. And we would make it to one calculation, 27 divided by everything down below, 1.008 plus 1.008 plus 16.00, and that will give us around 1.5 moles. So that will be 1.5 moles of water. But we have to notice that in water we have 2 hydrogen in every water. Every mole of hydrogen, every mole of water, it has 2 moles of hydrogen. Therefore, every 1.5 moles of water, we have 3 moles of oxygen, or 3 moles of hydrogen. So we have 3 moles of hydrogen. And one thing we can do is to times those things by 2. So we have 6, a ratio of 5 to 6 from carbon to hydrogen. And so it should means that empirical formula would be C5H6. And one thing we can see is D match our criteria. Therefore, or D would match our criteria. Therefore, D would be our final answer. Let's check. Perfect. Alright, we have everything correct. 4 out of 4 correct. Thank you very much for watching, and good luck on future chemistry. Thank you.